Hello everyone. This simulation is on the website of Hacker Earth. So all credit due to Hacker Earth for providing this wonderful simulation online. In this video, we'll take a look at a sorting algorithm which is called as bubble sort. Okay, so let's say we have some values which we want to sort. Okay, now starting bubble sort. What bubble sort does is it compares. For each pass we will move left to right, swapping adjacent elements as needed. Each pass moves the next largest element into its final position, which will be shown in green. So now starting pass 0. So in pass 0, for each element moving through the list, we'll compare the elements. So 5 is compared with 50. Because 5 is less than 50, that means 5 and 50 are in the right position. So we'll move ahead. Now 50 compared with 10. Now 50 and 10 are not in the right position because we want to sort that in ascending order. So 10 must be before 50. So what we'll do is we will swap 10 and 50. Now 50 is compared with 45. Again, they are not in the ascending order, not in the proper order. So therefore we'll swap them. Okay. Similarly, 50 compared with 15, swap. 50 compared with 40, swap. 50 compared with 20, swap. 50 compared with 35, swap. 50 compared with 25, swap. 50 compared with 30, swap. So now 50 has reached its final position. So this is done. Now we will only run the loop from index 0 to index 8. So again starting pass 1. So for each element we'll move through the list. 5 compared with 10 in right position, 10 with 45 right position, 45 with 15 we need to swap, 45 with 40 swap, 45 20 swap, swap, again swap, swap this, and 45 has reached its proper position. Now we'll work only in the area from 0 to 7. Okay, so 5, 10, 15, they will not need any swaps. Now 40 with 20, and now the swaps will start. So swap, 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 and swap. Now we'll only consider elements in the position 0 to 6. Again, now if you see, positions from 0 to 4 won't need any swap. Now 35 25 swap, and 35 30 swap. Now 35 is in its right position. So now all the elements are actually in the right position, but still the bubble sort will run for a certain amount of time. Now to save these extra iterations, what we can do is we can set a flag which will check that if there are no swaps in a particular pass, that means that our array is already in the correct or sorted position. So we don't need to keep on going through the algorithm. We'll simply stop there. If we find in any pass, if we see that there are no swaps, we can simply stop there. Okay, so this is done. Okay, the entire array is sorted. So this is the code for bubble sort. Okay, the logic is the same as we saw. For I equal to 0, I less than n minus 1, I plus plus. Okay, we'll keep a flag because as I said towards the end of the visualization, as we saw, even though the array was sorted, it still continued with the iterations. So what we want to do is, okay, in the inner loop, what we do, inner loop, how many times will it run? So inner loop will check from j equal to 0 to j equal to n minus I plus 1, I plus 1 in bracket. So it's like n minus in bracket I plus 1, that is n minus I minus 1. Okay, because the last element, then second last element, then third last element, all those elements are in proper position as we progress through the iteration, as we progress through I. Okay, so all those last elements will be in the proper position, so we need not um, go till the end of the array. So basically you can say that these are basically pass numbers. Okay, or this is basically pass. So the classical or the non-optimized algorithm will run for n minus 1 passes. Okay, we'll have n minus 1 passes, and in each pass the element at the last position, n minus 1, n minus 2, n minus 3, so on up to 1 and 0. So all the elements will gradually be in the right position. Okay, now we have initialized a flag over here called swap. Okay, so this library, which is standardbool.h stdbool, is available in compilers that support C99. If your compiler does not support this, you can use int swapped equal to 0, and 0 is considered false, as you might know, and any non-zero value is considered true. So you can use an int variable or a short variable as a flag. Okay, so now we'll check the adjacent element. So if element at position j is greater than element at position j plus 1, which should not be the case. Element at position j should be less than, because we are considering ascending order of elements, right? So therefore we need to swap the adjacent elements if they are in the wrong order. Now how do we swap? We create a temporary variable int temp and assign array of j, element at position j, to that particular temporary variable. Then arr j equal to arr j plus 1, because that is what we want. We want the value of uh, element at position j plus 1 to be stored at position j, and value at position j to be stored at value at position j plus 1. Okay, so value at position j we have stored in the temporary variable, and we have replaced the value at position j with the value at position j plus 1, and now we'll store the value at position j which we had stored over here in temp. We'll store it back at position j plus 1. So effectively array of j and j plus 1 have been swapped, and because there is a swap, we'll set the swapped flag equal to true. Okay, now just for ease of understanding for this program, I have made sure that we print the array after each iteration so that it will be clear to you. And finally, if not swapped, then break, because if there was no swap in any particular pass, that means the array is already sorted. Okay, so we'll run this for some example. Okay, let's see. So original array is this. Largest element is 90. 90 is in its right position in the first pass. In the second pass, you can see, so 34 is at its right position. And after pass 6, so although we have 7 elements, okay, now let's take the example of the array that we saw in the simulation. Okay, so for example, the array that we had taken was 15, 40, then 20, 35, 25, and 30. Okay, so this was our array. Okay, and as you can see, although we have 10 elements over here, so but still it does not go on for 9 iterations. It will stop at pass 5 when all the elements are sorted because of the swapped flag. Okay, and inside this, now just to illustrate a concept, okay, so size of arr divided by size of arr0. So size of arr, the entire memory allocated for the array, divided by, because here we have taken the array in this way. Okay, so you can divide the size of the entire array divided by size of single element, that will give you number of elements. Not necessary, but still works. Here, okay, we printed the array before sorting, and then here we pass the array by reference. Arrays are always passed by reference. Okay, and then because arrays are always passed by reference, whatever changes happen to the array inside the bubble sort function, those changes will be reflected in the main function, because we are passing the address of this array. So whatever changes take place over here, they are effectively changes taking place in this array itself. Okay, so then we print the sorted array. That's it. Thanks for watching.